Hello, hello, hello. 10.2 finding arc measures. Finding arc measures. So arc measures are measured in degrees. So in your notebook, you're going to put this in your notebook here on 538. So a center angle of a circle is an angle whose vertex is at the center of the circle. So here's circle C. Boink, there's your center of your circle. So if this vertex is at the center, this is called a central angle. That angle right there is a central angle. Okay. In this diagram, that central angle is angle ACB. That's central angle of circle C. Okay. If the measure of angle ACB is less than 180 degrees, if this arc is less than 180 degrees, then that forms a minor arc with the endpoints at A and B. So this right here is a minor arc. It's less than 180 degrees. If it's exactly 180 degrees, then it's called a semicircle. If it's more than 180, so say from A all the way around here through D and back to B, arc ADB, that would be a major arc because it's more than 180 degrees. Okay. Put this stuff in your notebook. Next, just lower on the page, we have these materials. The measure of a minor arc. So this minor arc, if this central angle is 50 degrees, then this arc, minor arc, will have the same measure of this central angle. If the central angle is 50 degrees, the arc is also 50 degrees. If this arc happened to be 45 degrees, then the central angle would have to be the same as 45 degrees. Okay, so this little M in front of this, it says the measure of arc AB. Now, what about a major arc? So this stuff you need to put in your notes put in your notes as well. The measure of an entire circle is 360 degrees. The measure of a major arc is going to be basically the difference between 360 degrees and their minor arc. So if that's 50 degrees, arc AB, the measure is also 50 degrees. Arc from A around D to B, that's more than 180. That's going to be 360 minus 50, which is 310. So that arc is 310 degrees. So if you see something like this, how do you know this is arc? These are different, by the way. This is arc RP, because there's an arc above it. This is just a segment from R to P. Arc RP, that right there in this circle is from here, from R to P along the circle. This right here is a straight line from R to P, from R to P. That is a chord. This is an arc. There is a difference in how you signify that, how you write that down. Okay. Now, how do you know if you want arc RP, the short one, or arc RP, the major arc? Okay, from R to P, you'll always default to the shortest distance from R to P. You'll always go from the shortest distance from R to P. So if R to P, it's the measure from R to P, that measurement. If you want the other direction, then you need to have another letter. So in this case right here, if I want to measure from R to M to P, then I would have to say that would be measure from R through point M to point P. Arc RMP, from R to M to P, that's going to be a major arc. That's more than 180 degrees. Major arc is more than 180. Minor arc is less than 180. 180 degrees exactly. So if we did this, if that was a diameter, and look. Give me any letter of the alphabet you want. X, good choice. If you say arc PX, which arc is it? Yeah, you have to be, if you want to be specific. If that's a diameter, then it won't matter because that's 180 degrees. That's also 180 degrees. But if you want to pick one over the other, if you want to pick this one, this would be arc from P to M to X. has an arc there. If I wanted that one, that'd be start at P, go through R, end at X. With an arc above it, like that. That's how you differentiate between one arc and another. Okay. Well, then you'll have adjacent arcs here. Arc addition postulate. Hey, if you take arc AB and add it to AC, you're going to get the measure of arc ABC. You can add those as long as they're adjacent. Okay, as long as they're all adjacent next to each other. Next, congruent circles. Two circles are congruent if and only if the rigid motion or composition of two rigid motions maps one circle onto another. It's another way of saying that, hey, if two circles have the same radius, they're going to be congruent. If their radius are the same, if their radii are the same, the circles are congruent. If this diameter is the same as that diameter, the two circles are congruent. Remember, the same size, same shape. Now, all circles are going to be similar because they have the same shape, but they're not necessarily going to be congruent. So this circle is bigger than this circle, but this circle is bigger than that circle. So they are similar, they're the same shape, but they're not the same size. So they're similar, but they're not congruent. These two are the same shape and same size. That means their radius, this radius and this radius are the same. Okay, the size and shape are going to be the same. For this one, this goes in your notebook right here. This is right there, gaboonga, boonga, boonga. Let's move it up there. In the same circle or in congruent circles, two minor arcs are congruent if and only if their corresponding central angles are congruent. Here's what that means. Make sure that goes into your notebook. Here's a circle. If this central angle is 70 degrees and if that central angle is 70 degrees, that means this arc is going to be the same measurement of that arc. They're congruent. If that's 70, this angle is also, this arc is also 70 degrees. If that's 70 degrees, this intercepted arc is also 70 degrees. This is the intercepted arc of that central angle. This angle goes out this way. Whoosh. Whoosh. That's the intercepted arc. Like a quarterback who throws an interception, that's what they mean by intercepted arc. Different context though. Hey, in this triangle, what are you talking about? In this circle, here's a circle, this arc is the same measurement as that arc. They have the same number of hash marks. If that's the case, that means this central angle and this central angle will also be congruent. Okay? Bada bing, bada bang, bada boom. Next, we have this right here. Boom. Here's an arc. It's a circle. That central angle is 165 degrees. This is going to be your center. Let's call any letter you want in the alphabet. A. So this is circle. It's Fonzie circle. Hey! What's the measure of DE? So DE, which way? You always go the shortest distance. From D to E. From D to E, this is the shortest distance. So from D to E, that's going to be 165 degrees. What if you want to find the measure of arc DPE? From D through P, end at E. Starts at D, goes through P, ends at E. So how many degrees in a circle? 360. 360 minus 360 minus 165. 10 minus 5 is 5. 2. 15 minus 6 is 9. 2 minus 195. So the measure of arc DPE is 195 degrees. Add these up together and you should get 360. You do. Let's turn it over. Let's do this. Circle F. Should have said K. Circle K like the store. Circle K. So baboomba. Let's move it out a bit here so I can see a little bit better. So we're going to circle K. All right. Hey, what's the measure of arc? No, arc NO. Here's N, here's O. What's the measure of that arc? This is circle F. That means that's the center. If this is 60, that's also 60 degrees. Boom, done. NV, Nevada, NV, Nevada. What's the measure of arc NV? 120. What's the measure of arc N to V to O? NVO. Do we just go NO? No. Where's V? It has to go through V. So N to V. Keep going in the same direction until we get to O. There. So that arc right there, an easy way to do it, instead of, I could add up 120 plus 30 plus 90 plus this, but I know a full circle is 360. 360 minus this, which is 60, is 300. So 300 degrees. Arc TP, toilet paper. TP, from T to P. So what's the measure of this arc? It's going to be the same as that central angle. What's that measurement? 90 degrees. So TP is also 90 degrees. OP, because of Mayberry RFT. OP, from O to P, from O to P. What's this? What? Wait a minute. So the whole circle is 360. We know that's 60. That's 120. That's 30. That's 90. All these angles have to add up to 360. So we need to get out. I know that this is going to be that's 180. These two add up to 180. That means these three also have to add up to 180. 90 plus 30 is 120. 120 plus what gives you 180? Has to be 60. So this arc is also 60 degrees. Boom, done. Okay, next, tell whether the arcs are congruent. Is this arc congruent to this arc? Remember, congruent means same size and same shape. They may have the same shape. They're not the same size though. This circle has a radius that big, that long. This circle, the outer one, has a bigger radius. So right away, since the radii are not the same, these arcs cannot be congruent. So is this arc LP? LP, is it going to be congruent to MM? MN? I don't mean the rapper. M&M. Is it going to be congruent? Nope. Arc LP is not congruent to arc MN. The radii are different. Okay, now keep in mind when you do this stuff, arc measure is done in degrees. Arc length, we haven't got to that yet, but arc length is measured in inches or feet or meters or centimeters. It has some kind of distance to it. Arc length is a distance. Arc measure is in degrees. So that's, you will find the difference, because at some point they're going to start saying find the arc measure, and somewhere in this chapter they'll say find the arc length. They're two different things, two different meanings. So keep that in mind. That's it. Boom, done in 14 minutes. Almost 14 minutes. Good enough. Hasta la. Bye-bye.